All right. So I am going to be doing a little bit of advent of code, getting my stuff all squared away here. So, advent of code, if you're unfamiliar, so if you go to adventofcode.com, 2024, there's coding puzzles. So, for instance, last year's day one, or yeah, day one, we were given this coding puzzle. Here's your input, and part one was, solve it this way. So zoom in on it, and it's, hey, look, this number, like from each line, you get a number. This number's 12, 1, 2. This number is 38, but it's only the first and last digit. So this is 15, ignore the 2, 3, 4. This is 77, since there's only one digit, do it twice. This was last year's day one. And so then when you look it up, you're given a generated input. So like my input, I'm not going to show the full thing, but my input was this. So the point being, it's long. You need to program to solve it in some fashion, rather than manually do it. Um, so anyway, solve this problem and put your answer in the text box. And what's nice about this is then you can use whatever language you want. Some people do like Excel, for instance. And then part two, it changed the instructions a bit. So that's kind of why I like Advent Code is part one, part two. I am not trying to get overall leaderboards because I just think that's just a fool's errand at this point, unless you're like actually one of the top competitive programmers like in the country. So what I'm going to do is I'm going to put the instructions up here. We're going to read through them. I'm going to copy my inputs in. So I have my development environment set up. I'm going to be using Kotlin. So that's what we're going to do here. So I already have sort of a setup where it'll read in some input, dump it into a list of strings, and then I write in the code for part one, part two here. But now we're getting close to time. So under a minute to go. I'm going to grab a sip of water real quick. All right, 15 seconds. So this starts at midnight every day. I'm going to try to go through these. Normally I probably won't start at this time of day because it's midnight and I have a baby, but I'm excited. So here we go. Looking at the instructions. So first, what is the background story? There's always something Christmas related. So the chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Okay. He's visiting locations of historically significant to the North Pole. A group of senior historians ask you to accompany. At each location is checked. You will mark it off. Okay, stars. All right, collect stars by solving puzzle. Yeah. Haven't even left yet, and the group of Elvish has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides the best place to first check would be the chief historian's office. Upon pouring into the office, everyone confirms the chief historian is indeed nowhere to be found. Instead, they all discover an assortment of notes, list of historically significant locations. This seems to be the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, historically significant locations are listed not by name but by a unique number called a location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. There's one problem. By holding the two lists up side by side, it quickly becomes clear the lists aren't very similar. Okay. Here is test data. At least I think. Maybe the lists are only off by a small amount. Find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, then second smallest, second. Okay. Sort. Within each pair, figure out how apart they are, the two numbers are. You'll need to add up those distances. For example, pair up a 3 with a 7, the distance apart 4, 9 with 3 is 6. In the example listed above, blah, 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 blah. So, okay, the total distance. Okay, so we have numbers on the left, numbers on the right. Here we go. This is my input. All right, so now that I have my list of lines, I want to get, this will be pairs equal yeah, I want to split on just any white space. Please don't do that, cat. That's not nice. No. All right. No, I think I can just do split on space. Sorry. Okay. If my cats continue to annoy me, I'm going to lose. Stop. Stop. 2 in midnight, and I just fed them, and they're still being assholes. All right. Okay, let me just check real quick to make sure this input looks reasonable. Yeah. Hi there. Well, I'd actually, it's funny you should say that. Last year's the first time I ever did it. Last year's the first time I ever did admin. Yeah, okay, so I want it dot split on slash space dot two regex. I just want two regex. I don't want this like whole ass thing. Oh, slash base plus. Okay, sorry. I'm trying to remember my regex. There we go. I got the numbers. Okay. So now, and then dot map into pair, dot to int, and to int. Okay, and then from there, get one results. This is just going to be this is now going to take in pairs, is a list, pair, int, and this one's actually pretty straightforward, not surprising, it's day 1, pairs dot sum of minus, but I want to make sure, here's the little bit, gotta do the abs, gotta get some abs in here. Okay, 13, does that match my test input? 11, what did I do wrong? Oh, I forgot to sort. Right. Yeah, you know, in hindsight, yeah, okay. Val L1 equals mutable list of int, forgot to sort. Val L2, and instead of mapping, we're just going to do dot for each. There, it's going to be L1 dot add pair 1 dot add pair 2. But this is going to be 0 and 1 just to make sure I'm not confusing things. L1, L2, and this is now L1 list int and L2. list int. Do L1s equals val L1s equals L1 dot sorted, and then it's map indexed index oh oh I don't really want to do that anyway. And then I'll right. Okay. Yep. 11. Okay. That was the test result. Yes. Okay. So now we just do that on the actual input. And we get this sum, which is a big number. And we put it in. Ta-da! Okay. So why is this wrong? Historians can't agree on which the two lists of locations are indeed very different, or are they? Can't agree on which group made the mistake or how to read. But in commotion, you notice an interesting detail. A lot of locations ID appears in both lists. Maybe the numbers aren't locations, but rather misinterpreted handwriting. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times it appears in the right list. So 3 appears 1, 2, 3 times. So immediately I'm thinking how I can solve this in n squared time and how I can solve this in, well, I guess it would maybe be log linear time. Yeah, I could do it in log linear time. I have to sort, and then I do a binary search to find the first, a binary search to find the end, and then like of the threes, yeah. Um, let's just solve it and then come up with a fast solution because I think my input's small enough I can get away with the n squared. Um, so okay, we're gonna take in L1, L2 again, and same inputs. And since we're sorting in both places, I'm just gonna do that here now. Oh wait, I gotta add the elements first. I'm going to include both sorted, and I'll sort of get to why. Um, First, let me make sure I didn't break anything. Okay. So the simplest thing is just L1. Okay, hang on. Right. Okay. Actually, it might be easiest to just do a linear map. Come to think of it. Val count map is okay. Grouping by this would be L2. Got each count. What is this? Oh, this is convenient. Grouping by the count. Awesome. Kotlin's such a great language. Such a wonderful standard library. Just like I understood grouping by it. I didn't know it had this each count thing. That's great. So then it's just gonna be This is going to be actually just sum. And it'd be it times count map it. No, is it not like this? Unresolved reference it. All right. Oh. Right. This is Elvis notation, and it just means because this could return null, that means that there's no element of it in the second column, and so in that situation we want to treat it as 0. Should work. Oh, I need to redo my test data. And then I'll sort of walk through what I did here. God, Kotlin is just so nifty to just have little things like this. What in the HE double hockey stick is going on? Okay. Yeah, I've heard this. I shouldn't have updated IntelliJ. This update of IntelliJ is appearing to be rather unstable, and I'm running into a lot of issues with it, so I'm just going to have to. This has happened multiple times today, and I looked online, and people were like, "Yeah, don't upgrade," which is, not a thing that you generally want to hear. But something about this particular patch of IntelliJ is causing multiple people problems. Okay, anyway. All right, there's my test input. Let's run. Okay, I got 31 on my test input, and yep, okay. Yeah. So then input, and there's my number. Not particularly close to long overflows, so keep minimizing the wrong thing. There we go. All right. Obviously did not make it anywhere close to the leaderboard in any way, shape, or form, nor did I realistically expect to. Um, rank. Yeah, I bet that time would have been better if I didn't have to restart IntelliJ, but I did. Also, in fairness, I was reading the problem out loud. I wasn't really going for speed. Out of curiosity, uh, what was the leaderboard time? I'm looking just to see if I recognize any of these names up here. There's a few like competitive programmers whose names I've seen year over year or at different like ICPC type events or something. Per day 1. 9 seconds? What? What? That is huh. I don't know what to make of that. Like 54 seconds I can believe. 9? Hmm. Hmm. Something smells of fish. 4 sec so 4 seconds to get part 1, 9 seconds to get part 2. I am pretty convinced that that would be AI. That seems not not on the up and up. I'm gonna call bullshit. Like when it's that big a gap, I don't know. I'm gonna call bullshit. Has anyone else on my private leaderboard done this yet? No, no one yet. Okay, I'm the only idiot who's gotten up in the middle of the night. Okay, so to explain map index. So first, um, to know what a map is take the things in this list, like take that item and run it through this function and basically turn it into this item. It doesn't actually modify the list. It's just creating a new list, but it's like think of it like a transmogrifier assembly on an assembly line. Just take each item, run it through this function, and there's the result. Map indexed is useful specifically when we want to take each item and get its index. Um, so here specifically, I want to map up like index 0, index 0, index 1, index 1, index 2, index 2. And so what's actually useful for me is to look at the indices, not at the actual value. And so this is like I could give this a name item, but like I'm not actually using this item. And so a way to sort of communicate that in code is just underscore. It's not syntactically necessary, but it's just a useful way to communicate like, hey, I'm not actually using this. From there, it's just get the sum of the absolute value of the differences. That's pretty straightforward. Part two, so grouping by means I'm going to group things. So I'm specifically looking at list two, and I'm going to group everything that has the same value. So it is the value of the number in the list, and I'm going to put them into a group. But I need to assign that group. So that's the key. The key makes a map, key value pair. The key is the number. And then I'm just mapping it to however many times that number appears, which is just a built-in thing, each count. This is just built into Kotlin because Kotlin is better than your programming language. From there, just go through list one and get the sum of, and the similarity score was the number times the number of times it appears in the list on the right, which is just an incredibly bad similarity score. It doesn't communicate similarity at all, but whatever. Um, this part is whenever we have a map, if I say, hey, map, like give me the value associated with this key. If like I have 3 to 5 in my map, and I say, hey, give me the value associated with 3, it'll give me 5. But if I don't have, say, the number 7, well, then it'll actually return null, and I don't want null. I want 0. And so, just question mark, colon, this is basically if null, instead use this, and I want to instead use 0. So, get the number of times the number appears in the second list, or if it doesn't appear, 0, because that's an accurate representation of the count, and then just return the number on the left times the number of times it appears in the list on the right, or 0 if it doesn't appear at all. And there you go. Kind of curious if this is accounted for. Let's just see. Should crash. Okay, good. I would want it to crash. That would imply that there is data that doesn't neatly conform to the idealized standard. So yeah, there we go. And 2024, day one in the books. All right. I don't need a variable name here anymore. I can probably do an optimization lines dot size. That might give me some micro optimization. So what did it take before? 393, 6582. That micro optimization help. It helps a little bit. This second phase is still slower. I'm surprised it's this much slower. Like, this is linear time, but so is this. Now, maps are slower than sets. Hmm. If I look at my input, it appears that nothing is larger than 5 digits. So given that, if nothing is larger than 5 digits, I wonder if val counts equals array, and this would be 5 digits, I would need 10,000. And then everything would be initialized to 0. This means create an array of size 10,000, initialize 0. But actually, I need 100,000. And this is going to be an array of ints. And then from there, I could do. Let me just see if this is faster. L2 dot for each counts it plus plus. And then I don't have this null safety check. Was that faster? Was that faster, or is this slower? Okay, 1616. I think, yeah, okay, it's a lot faster. So this is me doing an optimization here. And the optimization is instead of using a map, I use an array because I'm taking advantage of the fact that all of the numbers are 5 digits, which means their value is somewhere between 0 and 99,999. I'm just creating an array of size 100,000, initializing all the values to 0, and then just for each element, I just increment that index of the array, and then I get the sum. And it turns out that that is pretty doggone fast. Quite a bit faster, in fact. That's a significant speed up. So, case in point, hash maps not always the fastest, especially when my guess is there's probably a bit of a cost adding in that sort of null check. But yeah, all right, that's day one. Let me see. And then the other thing I do is add some comments, split lines on white space, and add to lists. Okay, and then right. Yeah, I mean, just this, like, just to show this little optimization, let's like delete this sort of initial size. So 237 and 1752. It actually doesn't seem to make a difference. That is interesting. Am I? Oh, wait. Am I adding a number that I shouldn't be adding to the front of this? Right. This would be. Um, okay. No, it doesn't actually have this. Um, yeah, I think I can do array list. Okay, so if I do array list, it's actually faster a little bit. And now I can do this optimization. Um, right, initial capacity. So that's a right. Okay, let's see if this helps. Surprisingly, doesn't seem to make a difference. What if I just use array int? Initialize them all to 0. Curious if the array is faster. This would now be for each index, and this would be I'm just kind of curious how if I can like just basically turn everything into arrays and make it faster. Part of this is just me sort of exploring different optimizations in Kotlin, noting that a lot of these things might already be optimized. Oh no, it's happening again. Connecting to VM. Not good. Not good, not good. Yep, it froze again. Ah, this is disconcerting. Um, Kind of annoying that IntelliJ is breaking. All right, let's see. Yeah, this is me just sort of playing around with like micro optimizations and seeing if it's worth anything. Is that much slower? Wow, that is seemingly much slower. Interesting. Interesting. Wow, that is weird. So when I was using just the hard arrays in there, it was actually slower. by a considerable margin for part one. That's it. That's weird. I guess it's probably just an optimization thing, sort of under the hood. But yeah, that caught me off guard. Anyway, all right. For 2024 day one up. Let's try to avoid um 2 sorted. I try to avoid abbreviated variable names. And also just making it clear that these functions assume sort of, to be clear, I could sort inside of these functions. I'm just trying to avoid recalculation of like sorting in here and then sorting again in part two. Um, the sort of trick to that is now I'm gonna have to assume these are sorted. Yeah. So let's see. List one, list two. Oops, I didn't do a refactor. I just what's the commit hotkey again? Control K. Okay. There's not like a hotkey for that. Maybe tabbing works. And really try that. Then Control K for commit, Control Shift K for push. That makes sense. Trying to keep my hands sort of off the keyboard. See what I can do with that. All right, that's day one. Take care.